Friends, today we are going to discuss different type of cooling tower installed in industry. So cooling tower can mainly categorized in two types. That is one is called natural draft and another one is called mechanical draft. Natural draft, this is natural draft. There is no fans etc. are used. Natural draft the use very large concrete chimney, very large concrete chimney. The chimney is very large, taller also. Very large concrete chimneys to introduce air through the media. Hmm. Due to large size of the tower, they are generally used for water flow rates above 45,000 meter cube per hour. And this type of tower are normally used in utility power station. The very bigger size, concrete and fields are also used, and that's why as the size is big, so cooling water flow is also requirement is also big. That is above 45,000 meter cube per hour. And the power station normally we are using natural type, natural draft type cooling tower. And mechanical draft tower utilizes a large fan. This is the fan, induced fan. Sometimes a fan is also forced draft fan is also used. FD fan. Use large fan to force or suck air through the circulated water. Air, if it is forced draft, then air force the air, and induced draft suck the air. So through the circulated water, because water is circulating, the water fall downwards over the fields, over the field surface, which help increase the contact time between the water and the air. If fields is there, that's why water and air contact time will increase. If it is field is not there, then water will directly go above, bypassing some contact with the water. So fields is there. So if we are using fields, then water contact will be more. Air contact will be more with the water. Heat transfer, that will help in heat transfer between the two. And cooling rate of this mechanical draft tower depends upon their fan diameter, how much fan diameter is there, their speed as well as their speed. And mechanical draft cooling tower are much widely used in the industry rather than the concrete. This is the advantage. And these two types are mainly two types. That is, one is a natural draft, another is forced draft. Natural draft, there is no fan is there. Due to natural temperature difference, the air will flow through this. There is a fields are there, it will go directly, the density difference, air will go upwards. Next is the advantage and disadvantage of natural draft. Natural draft, why that is the advantage? Now its operation and maintenance cost are are less, since no fans are needed. Here natural draft, there is no fans are natural draft, there is no fans are required. No, there is no fans are required. Air will flow through this due to temperature difference. There is no fan is required. That's why maintenance is less. Maintenance is very less, and it create its own draft, assuring efficient operation even when there is no wind. Then also it will work, because water is dropping from the top, where it is dropping from the top. So automatically when it will come in contact with the air, it will automatically cool. So if there is no air, then also it will work. Longer life because it is made of concrete. And disadvantage is the high capital cost, because to manufacture this cooling tower, natural cooling tower with concrete, is very high cost is involved. And performance varies with the seasonal changes, because the hot season you cannot increase the air flow. That's why it is seasonal. It is performance are varies with the season changes. Now, mechanical draft fans can be of two types. That is, one is called counter or cross flow. Counter and cross flow. This is called counter flow, when water is, you see, from the top falling downwards and air is falling, moving upwards. So there is a direct contact, opposite direction. So that's why it is called counter flow. And here cross flow means air is flowing perpendicular to the water flow. You see here it is water flow through, there is two basins at the top. Here the pipes, to the pipe there is nodules, it will into through pressure water will fall. This is the fill material, this is the fill material. Here it is gravity, there is some nodules are there, spray nodules are there. From here the water will fall through the gravity, and air will go come in contact and are perpendicular and go through the center. And this is the fan. This is the fan. Here also this is the fan. This is the fill material. Here also it is the fill material is there. Fill material. And then this is the basin where hot water, and where it is cold water, collection of cold water basin. So this is the difference of air and flow difference. That is the counter flow. Air will flow directly opposite direction to the water. Here air flow perpendicular to the water flow. That is the main differences. And the selection also depends on the counter flow and or the cross flow, depends on the user requirement and considering various consideration. I think it is clear. Now the comparison between counter flow and the cross flow cooling tower. The performance, first performance, the counter flow cooling tower deliver higher performance than cross flow cooling tower, because here direct contact, air is direct, come in direct contact with the water. So here performance will be better than the and direction is opposite. So here heat exchange will be more. So it is much parameter performance will be better than the cross flow. And the cooling water can even be designed with an approach of below 2 degree economically. What is approach? Approach is the cool water outlet temperature and the wet bulb temperature. Wet bulb is the maximum cooling cool temperature you can achieve, and it can show in the counter flow you can reach very near to wet bulb temperature, that is with 2 degree below 2 degree is also possible near to your wet bulb temperature. Here lower approach temperature near to wet bulb temperature can also possible, but the space requirement will be very high for the cost flow high, and it may not be economical for lower approach design. And if you want to design it very near to your wet bulb temperature, cooling water temperature, then it is not very economical. In general performance, the cost flow cooling tower are lower than the counter flow cooling tower, because direct heat exchange means water is air is come in contact with the water horizontally, not directly. They are crossing each other opposite direction. Not opposite direction. That's why its performance is lower than the counter flow. Then space requirement here it is lower in the counter flow, and space requirement cross flow it is space requirement will be for similar duty are high. Then footprint, naturally it is space requirement is less, so footprint is also lower. Here higher footprint is required. Then counter flow cooling tower have the maintenance axis is very limited axis, it is closed in every direction due to its compact design, but here it is in the center. You will get sufficient space so that you can do the maintenance. If you see the drawing again, you see here a lot of spaces are there. So in air is coming this side, air is coming from this side horizontally, there are a lot of space are there, so you can do the maintenance. But here it is closed, both sides closed, there is no maintenance, you cannot do any maintenance, particularly for the counter flow. That's why counter flow maintenance is very difficult. Compact design, here maintenance is possible. Then water distribution here, water distribution counter flow cooling tower are through the header and branches from which pipe network of distribution with nozzle are installed. And here in the basin, water will come, and through the gravity is used for water distribution. Rectification and distribution can be done in operation condition. In operating, if you see the drawing again, you see here it is on the basin, water will come to the basin, and there is holes are there, and even choking is there, nozzles are there. Choking is through gravity only it will flow. So you can remove the whole size, clear the whole size. Here through the pipe it is coming, and through the pipe, and pipe having the nozzles, so through force it will come down. So you cannot do any maintenance here, but here you can do operation condition also, you can do the maintenance. Then second, then other point are low load operation. Here in the counter flow, if it is water load is less than 70%, then your counter flow cooling tower performance will be lower. Is not effective. Not the tower counter flow cooling tower performance deteriorates where below 70% water distribution. What I mean, cooling water distribution. Cooling water is capacity, suppose 1000. If it is 700 meter cube per hour, then its operation will not be as effective as 100 meter cube per hour. Here it does not depend on the cooling water flow, so it is major and has no effect, can be operated till 30% of the hydraulic load without having a major effect on the performance. So 30% load, it can be water load, on a cooling water load, it can be operated, but here performance will not be changed, but here below 70% performance will deteriorate. Then water quality, here water quality should be very clean, because suspended material, not suitable for suspended material, because suspended material is there, heat exchange will be very difficult, and water quality is very important for operating counter flow cooling tower. But here some suspended particles can operate with higher suspended particle, and water quality parameter can be relaxed. Here water quality can be relaxed, but here water quality should be much more stringent, because it come in contact directly in opposite direction with the air. Then air requirement, here air requirement will be low, because there is no question, no air is bypassing, but here lot of air are required high, high, because airflow requirement is high, because non-utilization of complete air during cooling tower performance. I will show you the if you see the drawing. Here you see here there is no question of bypass, because this side is closed, this side is closed, so there is no question of any water air bypassing. Here there is a air bypassing is there. You see air from here, here it is open. Here it is open, here it is open. From air is coming from the this side. Here air is coming from the bottom. Here it is coming throughout the length, So and not only that, from here also air can bypass. From here also you can air can bypass the fan. So air requirement here will be more, but here air requirement will be less, because it is compact. It is compact. Then counter flow cooling tower, already I explained. Water flow requirement is low, and higher fan pressure head is required, as it has to overcome the counter flow, because it is it has to overcome the counter flow of water. So air direction is upward, water direction is bottom downward. So lot of air pressure is required to counter the water flow. So air pressure will be higher. Here, as it is no pressure head is required in the system, as the head is developed by the hydrostatic head due to gravity, because here water is falling with basin at the top, and hydraulic and with the gravity, so pressure will be less. So here pressure will be less, so air fan pressure is not required, particularly in compared to counter flow, it is not so high. Then fan power, there as the fan pressure is more, so fan power requirement for inter counter flow cooling tower will be more, and cross flow air cooling tower it will be less, because it is not directly come in opposite direction. Does not come in water is and air connection is horizontally, so it is pressure requirement is less. So power requirement will also be less. So water spillage, here there is no water spillage, it is closed from the top, air is flow from the bottom. So there is no question of any air water spillage, but here at the basin or at the top, so basin are at the top, so water can spill from the basin. Water can flow from the basin. You see, from here water can flow. Spillage is possible, but here everything water is coming on through the pipe, through this nozzle. So there is no question of water will spill out. But here waters can spill, quantity is more, then waters can spill out outside. Outside, it can go outside. So here there is no question of spill out, because as it is, water is closed inside the nozzles, inside the pipe, so there is no question of any overflow. Here overflow is there. Here overflow is possible in the cross flow. So cross flow is possible. So what is Phillips problem is there. And then growth of algae. Here, as there is not come in contact with the atmosphere, sunlight, so algae formation is not possible, because water is flowing inside. Water is flowing. You see, water is flowing inside the tubes, inside the pipes. So no water is come in contact with the air. But here you see the basin are at the top. So air is coming directly contact with the air. Sunlight is directly coming in contact with the basin. So algae formation is there. If water is come in contact with the air for long time, algae formation is possible. Where it is inside that tube, inside the pipes, so no question of any algae formation. Algae formation means it can close, choked the nodules, etc. But here it is, as it is not come in contact with the sun, so there is no question of any choking. Prone to dust, not prone to dust, because water is inside the tubes, inside the pipes, so there is no question of come in contact with the dirt. But here it is possible when a basin, outside basin, and air is also coming from the top at the from the sides. So dirt air can dust can mix with the water. Lighter operation weight, because area is less, so lighter weight is lighter. Here weight is heavy because area is more. For same duty, area is more, so it weight is also high. And noisier than the cross flow, due to the fall of water, because water is falling from the top at high pressure. And counter flow, the contact sound will be there. But here it is operation there is no noise, quieter operation than counter flow. So this is the main differences between counter flow and cross flow cooling tower mechanical draft. Then mechanical draft fans are of three types. The counter flow induced draft, counter flow induced draft, counter flow induced draft, counter flow forced draft, and then the cross flow induced draft. This is the cross flow. This is the cross flow. Water is falling down and air is coming horizontally. The cross flow induced draft, because only there is no, it is not possible to give any air from the bottom force flow. So it is induced draft. This is the single two side double flow. Here it is single flow, one side flow, induced draft, induced draft, cross flow, but say single flow. Single flow. But in your this is, you see here in the counter flow, it is counter flow. Air is going up and water is flowing down. Air flow is both FD and ID fan is when a balanced draft is possible. ID, FD fan, both you can use, or FD fan or ID fan you can use. But in cross flow only induced fan is possible. Induced fan is possible. So cross flow is induced draft, counter flow forced draft, and induced draft. In the counter flow induced draft design, hot water enter at the top while air is introduced at the bottom and exit at the top. Both force and induced draft fan are installed. Is possible. And cross draft only induced draft fan is possible. No forced draft fan. Now forced draft and induced draft. What is the difference between forced draft and induced draft? Forced draft means FD fan. It is at the bottom. Air is flowing at high pressure. Here the induced draft. Here it is creating vacuum and sucking the air from the bottom. Sucking the air from the bottom. Here air is forced from the bottom. Here sucking the air from the bottom. That is the difference between induced forced draft and induced draft. Forced draft and induced draft. Here you see the air is going forced draft as the air is flowing upwards, so some water will drift out. It will going out along with the air, so it will be water loss will be more compared to the induced draft, because you see here fan is at the top, so only through vacuum it creates some vacuum, so it cannot suck the water, because due to gravity water will fall down, but here it is force, water droplets will go upwards. That's why here water loss will be more. Then what is the advantage or disadvantage of forced drop cooling tower? Now advantage is the more efficient, because more air you are producing, more air you are supplying. Problem of blade erosion, because problem of blade erosion are avoided, because here no water is come in contact with the FD fan, so erosion is not possible, or possible. Then fan is located at the ground, so more safe. Vibration and noise are less in mechanical equipment are set on the solid foundation. Vibration will not be there, but induced fan, there is no concrete is not there, it will be resting on the wooden planks, so vibration will be there, sound will also be there. The disadvantage is the possibility of recirculation of hot, humid exhaust air coming out from the top of the tower, because we have already it is the hot humid air, because there are a lot of water droplets will come out along with the air, so humid air will be humid, particularly for the forced draft system. Then fan size is limited to 4 meters. Only the air fan size is small. You see the fan size is small. Fan size is small. Here fan size is bigger. Fan size is bigger. And then fan size is limited to 1 inch, and possibility of ice formation on the fan blade in cold weather. In cold weather, because there is a possibility that ice can form a ice formation on the fan blades, because due to cool, it is at the bottom. And then next is your induced draft. Advantage and disadvantage. Induced draft, what is the advantage? The coldest water come in contact with the driest air, and the warmest water come in contact with the moist air. What is this? The coldest air come in contact with coldest air come in contact with the driest air. If you see the picture, you see the coldest air. This one is the coldest air. Dry air come in contact with the water which is coming down. It will be cooler. So dry air is come in contact with the cool air, and hot air is come, because here air is coming, now it is kind of going upward, it will be moist, because it will come in contact with the water, and it will be come in contact with the hot air, because hot water, you see this is the hot water, and air is also moist, and here it is cold water, and air is dry. That's why it is much more efficient. It is much more efficient. It is much more efficient. eh, Much more efficient. Then recirculation of hot humid air is not a major problem, because in the in your induced draft fan, if you see induced draft fan, there is air is not humid. Here air is humid, because air containing some water outside. Here due to gravity, water will fall downwards, air will go upwards, so there is no question of any water going outside. Water will go certainly, but less. Water will be less. Then problem about and blade erosion. Then blade erosion. Then your larger fan size can be used, because it is possible to use a larger fan size. You see, this is a larger fan size is possible. This is larger fan in the induced draft fan. Larger fan size is possible, and lower first cost due to reduced pump capacity. Reduced, because less water is going out, so makeup water quantity will be less, and capable of cooling through the wider range. Capable of cooling through the wider range. Wider range is possible, and cooling water in and cooling water out temperature range, it is possible. It can be run with that, with the that, and range is high. And here induced draft fan, the disadvantage is not economical up to capacity, because 15,000 liter per minute water capacity is not so economical. Uh, if it is more economical, then the quantity is very high, and higher power motor is required because it is handling uh, more air, more air. That's why higher size motor size is required uh, to drive the fan compared to forced draft. Forced draft fan, small air is required, and induced draft fan, lot of airs are required because all air are not come in contact, not utilizing. Then maintenance cost is high because the fan will come in contact always with the moist air. So erosion will be there. If you see, it is erosion will be there. You see, the fan when it is running, it is come in contact with the water, also water droplets, water, moist air. So erosion will be there. Here you see the fan is in the outside, so there no, it is not direct contact with the water. So it is erosion. Maintenance cost will be high. Maintenance cost is high, and fan bearing need to be cooled. Here fan bearing also need to be cooled. Need to be cooled because it is hot air is going outside, so need to be cooled. Cooling is required. So I think, friends, we have discussed thoroughly in detail what is the different type of cooling tower, that is natural draft and mechanical draft. Natural draft are very bigger size concrete, hyperbolic shape, uh, and very high, tall in length. Its initial cost is very high. The only disadvantage is that it affects it is with the weather change, because there is no fan is used, so you cannot increase the airflow, but it can be used widely in all season. But seasonal effects is applicable in natural draft. Only initial cost is high, maintenance is less. Mechanical draft, I have already told you that it can be of counterflow, it can be of cross flow. Advantage and disadvantage of counter flow and cross flow has already been explained in details. And what is induced draft fan and post draft fan is possible in use for counter flow, and induced fan only used in cross flow. And cross flow and counter flow requirement depends on the different parameter of water, like water quality. If water quality suspended material is very high, then counter flow is not suitable, cross flow is suitable. So we have discussed each and every point. If you go through the slides, you will understand it very well. And if you are satisfied, I request you to give a tick mark, like mark, and subscribe this channel, so that you will get a lot of other posts are going to come for cooling tower. Not only that, all mechanical equipment already, rotary equipment I have already explained, alignment already explained. So now the static equipment, boiler will going to come, heat exchanger is going to come, pressure vessels is going to come, lot of project work is also going to come. So subscribe it, and will come to know time to time what is the topic we are going to cover. And I think it will very helpful when you will face the interview board, final year mechanical engineering student, graduate engineers, the higher experienced fellow, and newcomers are all will be benefited in this channel. So I request, if you are satisfied, if you want more, if you have any doubt, you can contact me in my mobile number, in my email ID, or you can convince your management so that a video conference can be arranged by mutual agree, and that will clear your further doubts if any. So thank you very much.